In this video, we're going to talk about three important definitions. What it means for a function to be increasing, decreasing, or constant on open intervals. A function is increasing on an open interval if its graph goes up from left to right on that interval. That's not a very formal definition. We'll see a much more formal math definition here in a moment, but right now this is an intuitive understanding of what it means for a function to be increasing. If its graph is simply going up from left to right, that means as the x's increase, so are the y's. That function is increasing. A function is decreasing on an open interval if its graph goes down from left to right on that interval. Again, from left to right says I'm going that way in the domain, kind of forward from left to right, from the small axis to the large axis. If the function's decreasing, that means the y values are getting smaller, which means its graph would go down from left to right. And then finally, a function is constant on an open interval if its graph is a horizontal line on that interval. Constant, no change. All the y values will be the same. So let's see a function that has open intervals on which it's increasing, decreasing, a constant, and see if we can write those down. Before we do that, let me point out one important thing. These definitions are only for open intervals. So let's make sure we know what an open interval is before we go on. If I was to draw a number line, there are three different ways I could talk about intervals on that number line. I could do something like this, where I start at -1 and I end at 2, and I include both endpoints. Well, I would write that down -1 to 2, and when I include both endpoints, that interval is called closed. Another thing I could do, if I just erase that and don't include the endpoints, that turns from this interval to this one, +2, with parentheses, and that interval is called open. Open intervals do not include their endpoints. So when I'm talking about when I'm talking about increasing, decreasing, and constant, I'm only thinking about these kind of intervals. I'm never going to use something with brackets, no matter what's in the domain. And I'll show you that, explain more about that in a minute. There's a third option here. If I fill in one of the endpoints, that would be from -1 to 2. And that's neither open nor closed. So neither open nor closed. Oh, while we're talking about intervals, let's just talk about one more set of possibilities. Let's say I wanted to shade everything from 1 to infinity. Right, that would be that, from 1 to infinity. I'm not including the 1, and I never include infinity. Infinities always get parentheses because you can't include infinity. Never use a bracket on an infinity. And of course, I could think about turning that around the other way. That interval would start at -infinity all the way over there as far as it goes with that arrow and ending at 1. Well, I'm going to fill that in so I get to draw a bracket there. And then the only other possibility I could think about is if I shaded the whole real number line. All real numbers from -infinity to infinity. That's the whole real number line. This is actually a special one. The whole real number line is actually both open and closed. It's special. All right, so function's increasing on an open interval if the graph goes up, decreasing if the graph goes down, and constant if the graph is a horizontal line over an interval. We're only going to be using open intervals to describe this. Let's take an example. So here I have a function graphed. I'm going to call this function y equals f of x. And I want to find the intervals. Find the open intervals on which the function is increasing, decreasing, and constant. Oh, I think grammar's better there if it's an or. All right, so I'm looking for all three kinds of things. And intuitively, we have this idea of going up for increasing, going down for decreasing, and constant, always thinking about from left to right. So let's look at those places where we think the graph is increasing. And so I see a nice spot here where as I move from left to right, it looks like I'm going up. So I think that's increasing. minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8. Always open intervals. Doesn't matter that that's filled in, because if I think about it at this point, if I just plotted 1 point, right? I didn't know anything else. Just plot 1 point. You can't tell if we're going up, down, or constant. I always have to have at least 2 points, right? That's infinitely many. It's a little line segment to tell if I'm going up or down. And that's why we only worry about open intervals here. At this endpoint, I'm really not doing anything until I move to the right a little bit. And then I know I'm going up. So from minus 8 to minus 6, we're going up from left to right. So that's the spot where we're increasing. So now let's just go on and find anywhere else we think we're increasing. And from here to here, we're increasing. So that's from 0 to 2. And then finally, from, let's see, 1, 2, 3, 4, 5, from 5 to 7. Notice we're not using union symbols here because I'm not guaranteed to be increasing on points shared between these, right? I have to pick a point between minus 8 and minus 6 to be guaranteed to be going up from left to right on this place. I can't necessarily pick one from here and one from here. And so for increasing, decreasing, and constant, we never use unions. We just list out the different intervals. For example, maybe this piece wasn't up there. Maybe it was down here. And we'll just cover that up for a moment. If I pick an x value here and an x value here, we're not going up from left to right. I definitely went down. So I don't put a union. I have to list it out saying, hey, I only get to pick x's between 5 and 7. All right, well, I want to put that back the way it used to be. And look for any spots where my function is decreasing. So the graph's going down from left to right. Well, here we have a nice spot, and that's from minus 2 to 0. Then finally, where is it? Constant. Well, this is spots where we have a horizontal line, and I see 2 of them, and that's from, let's say, 1, 2, 3, 4, 5, 6, minus 6 to minus 2, and then again from 2, 3, 4, 5, from 2 to 5. And we found all the intervals on which our function is increasing, decreasing, or constant. Well, I want to do one more example. But what I would really like to do first, before we get to that example, is see the rigorous mathematical definitions of these terms. And so I have them written down here. And we'll get to the example drawn there at the bottom of the board here in a minute. But for right now, I just want to take a peek at these more formal definitions. I'm going to add something to my diagram, and we'll get to it here in a minute. All right, so before we had a function is increasing if its graph is going up from left to right. And here what I have is a function is increasing on an open interval I if f of x1 is less than f of x2 whenever x1 is less than x2. Well, let's make sure we understand what that's saying. So on the x-axis, I have 2 x values, x1 and x2. x1's on the left, x2's on the right. X1 is less than x2 means we're reading from left to right. This is mathematical notation for y values, and it says I have some y value at x1, and the y value at x2 is higher. So for any choice of x1 and x2, I've gone up from left to right. So mathematically, this pairing of things says as I move from left to right, I'm going up. A function is decreasing on an open interval I if f of x1 is larger than f of x2 whenever x1 is less than x2. Well, it's that same idea. It's just now the larger y value is over x1 and the smaller one's over x2, meaning I've gone down from left to right rather than up from left to right. And then finally, intervals on which I'm constant on an open interval, every choice of x and y gives me the same y value. Meaning, if I have x1 and x2, all the y values have to be at the same height. All right, so these are the formal definitions, and they are nice to see and nice to use, and they will come up from time to time, but I never want us to forget the intuitive ideas that we had first, because they will always help us identify these intervals we're looking for. Increasing functions go up from left to right, decreasing go down from left to right, and constant functions are horizontal lines. So on open intervals, we go up, we go down, or we're constant. All right, so let's do this one more example here. And so I have a function, and again we're asked, where is it increasing, where is it decreasing, and where is it constant? So first, I'm looking for anywhere it's going up from left to right. And so I see this nice happy piece there. And so let's see, that's at -1, -2, -3, -4, -5. And I think that's supposed to be at -3. But this is why on graded assignments, I always use a computer to generate these images so that there's no ambiguity. So we're increasing from -5 to -3. And over here, we're increasing from 2 forever. Always increasing after that. That keeps going up from left to right. So on that giant open interval from 2 to infinity. Decrease. Oh, I missed a spot. Let's fix that. That was true, but I'm also going up to left to right in a very circle way right there. And so that's from -1 to 0. Well, I'm glad I caught that before I got too far down the road. And now I have found all the spots where I'm going up from left to right, even though this one's sloping slower and slower as I get to x equals 0. All right, now I need to determine where my function is decreasing, and I'm decreasing from 0 to 2. Now, one thing that's always important, when I'm thinking about reading from left to right, these are x values, right? I'm always thinking about where I'm going up from left to right. I'm thinking about open intervals in the domain. Right, and so 0 to 2, that's where this thing's going down from left to right in the domain. Always looking at these values in the domain. All right, now I'm looking for anywhere it's constant, anywhere that looks like a horizontal line, and I see that right here from x equals -3 to x equals -1. And there we have it. That's how you identify where a function is increasing, decreasing, and constant.